Hey everyone, welcome back. Today, we're going to take a deep dive into something pretty wild, something that might just totally change how you think about time.
It might even change how you experience it.
Exactly. We're going to explore this idea that, well, that time isn't just some separate dimension ticking away in the background. What if, and get this, what if time is actually energy?
And you know what's really wild is that we're not just messing around with philosophical stuff here. This is like hardcore science.
Really?
Yeah. We're talking about formulas, observations from the cosmos, the whole 9 yards.
Wow. You've got my attention now.
We might even find a new equation in this deep dive, one that goes way beyond even CA.
Okay, I am so ready for this.
You and me both.
So we've got a whole stack of research papers, theoretical models, and they all seem to point to this mind-blowing connection between time and energy. Where do we even begin with all this?
Well, let's start with the basics. There's this simple formula that actually links energy, time, and entropy. One of the sources actually lays it out. The equation is AT8E.
Okay, let me write that down. Ake. All right, got it. But what does it all mean? Like, break it down for me.
So HE represents the change in time. And that's Planck's constant. It's like this fundamental number in quantum mechanics.
Right.
And then 8E, that's the change in energy.
Okay.
Basically, this equation is telling us that as energy density decreases, time slows down.
Okay, so in places where energy is super concentrated, like near a black hole or something, time would move slower compared to places with, like, way less energy.
You got it. You're picking this up so fast.
I try.
Think of it like this. Imagine a crazy, busy city center, people rushing everywhere, bright lights, traffic jams, tons of energy, right?
Totally.
Now picture a quiet, peaceful countryside. Everything's moving slower, way less concentrated energy.
Yeah.
You see what I'm getting at?
It's like when you're on vacation, time feels like it's moving slower compared to a crazy workday. Is that kind of what we're talking about here?
Exactly. It's a great analogy. And what's really cool is that this connection between energy and time isn't just some abstract idea.
Really?
Nope. We've got actual scientific evidence from space that backs it up. Hard proof.
Right. Now you're really talking. Real-world observations, not just theories. Let's hear about these cosmic proofs.
Okay, so one of the biggest pieces of evidence comes from something called cosmic redshift. So as the universe expands, all the energy in it gets spread out, becoming less dense.
Okay, I'm following you.
And get this expansion actually changes the light waves traveling through space.
Whoa, wait. You're saying that as the universe expands and the energy density decreases, light itself changes. How does that even work?
It's pretty trippy. Imagine a balloon with little dots all over it. When you blow up the balloon, the dots get farther apart, right?
Yeah.
Just like galaxies in the expanding universe.
Right.
Now imagine light waves traveling between those dots.
Okay.
As the balloon expands, those light waves get stretched out, and that stretching shifts the light towards the red end of the spectrum. That's what we call redshift.
Oh, I get it. So the farther away a galaxy is, the more its light is redshifted. That means it's not only moving away from us, but the light has also traveled through a universe where the energy was, like, thinner and time, maybe it was flowing differently, right?
You nailed it. It's almost like our telescopes have a built-in time machine. We're looking back in time, back to when the universe was younger, and, well, time itself wasn't ticking the same way it is now.
Whoa, that's incredible. So cosmic redshift actually proves that time has been stretching as the universe expands and the energy density goes down.
Precisely. Time isn't this rigid thing. It's connected to energy. And we've got even more evidence from another crazy phenomenon, black holes.
Black holes, now we're getting to the good stuff. Those massive objects with gravity so strong that nothing, not even light, can escape, right? How do they fit into all this time as energy stuff?
Well, black holes are basically like giant energy bundles. They have insane energy density.
Right.
And if energy really does affect time, then near a black hole, time should basically slow way, way down.
Let me see if I got this. Because black holes have such massive gravity, and gravity is, like, connected to energy, time slows down near them.
You got it?
Wow. So it's like watching the rest of the universe on fast forward while you're near a black hole.
It's pretty mind-bending.
Totally. Okay, so we have this redshift thing and black holes, both pointing to the idea that how much energy there is affects how time flows. Is there anything else that supports this idea?
Actually, yes. Remember the cosmic microwave background? The CMB?
Yeah, like the baby picture of the universe.
Exactly. It shows us that the early universe was incredibly hot and dense, packed with energy. But as the universe expanded, it cooled down, and that energy, well, it spread out, leading to the cooler, bigger universe we see today.
Wait, so energy density again. Because the universe was so energy-packed way back then, time must have been totally different, right?
You're on fire today. It's fascinating, isn't it? We can look back in time and actually see how time itself has changed along with the universe.
This is blowing my mind. So, black holes, redshift, the CMB, they all point to this incredible idea that time is actually energy, not just some separate thing ticking away. It's a part of the universe, just like everything else.
And this changes everything. We've always relied on Einstein's EMC saw, but now we're realizing maybe it's not the whole story.
So we need a new equation, something that includes time in a bigger way.
That's what some of the research suggests. They're proposing a whole new equation, one that builds on Einstein's work but takes things a step further. They think mass, energy, and time might be connected in ways we haven't even imagined yet.
Wow, a new equation to describe the universe, that's next level.
Right. And this brings us to something else. This idea that black holes aren't just holes, they're more like time compressors.
Okay, I'm all ears. Tell me more about black holes as time compressors.
We usually think of black holes as giant space vacuums sucking everything in, right?
Yeah, kind of terrifying.
But what if they're not just empty spaces? What if they're regions where time and space get squished because of that crazy high energy density?
So black holes aren't empty, they're just like super compressed time.
That's the idea. And it actually makes sense when you think about all this evidence we've been talking about. It makes you wonder about the nature of gravity, space, even time itself.
Mind officially blown. Black holes as time compressors. Time connected to energy. It's all so much to take in. But what about the practical stuff? What can we do with all this, with understanding time this way?
That's where things get even more interesting, especially when we start talking about manipulating time. Imagine if we could control energy to actually control time.
Whoa, hold on. Are you saying we could, like, mess with time?
You might be able to. This opens up some crazy possibilities in quantum computing, like building quantum computers that can change how fast or how slow they compute by literally messing with time.
Okay, I got to hear more about this. But first, can we just pause for a second? My brain needs a minute to process all this mind-blowing stuff.
I get it. It's a lot to take in. We've covered a lot of ground here. But that's what these deep dives are all about, challenging our ideas about reality and, well, opening our minds to new possibilities.
Totally, and I am so ready to keep diving into those possibilities.
Let's do it. Welcome back. Before we jumped into all that quantum stuff, we were talking about black holes as time compressors.
Right.
And this whole idea actually comes from Einstein, his theory of general relativity.
Yeah, general relativity, that's the one where gravity warps space-time.
Yes.
I gotta admit, though, it's a little fuzzy for me how that connects back to black holes and time compression.
Oh, absolutely. Let's break it down. It all goes back to gravity and how it affects time. And of course, gravity is connected to energy, remember?
Okay, yeah.
So Einstein's theory basically says that the more massive something is, the stronger its gravity, and the more it'll warp the space-time around it.
Okay, so near a black hole, where the gravity is just insane because of all that mass, time would have to slow down, like a lot, right? Has anyone actually seen this happening? It all sounds like, I don't know, science fiction.
It does, doesn't it? But it's real. Scientists have actually used these super accurate atomic clocks to measure tiny time differences between spots on Earth and in orbit, where gravity's a bit weaker.
Really?
And you know what? The clocks in orbit, they tick a little bit faster.
Whoa, that's wild. Even though the time difference is super small down here on Earth, it still proves that gravity does mess with time.
Right.
So if you scale that up to, like, a black hole's gravity, it's got to be like time almost stops.
Yeah, it's like hitting the pause button on the universe.
Yeah.
That's why it looks like time stops at the edge of a black hole, at the event horizon. It's not that things are disappearing, it's that the energy there has twisted time so much that, well, it doesn't look like it's moving to us.
So warp time. Got it.
Yeah.
But how does this connect back to the cosmic redshift thing we were talking about before?
Yeah.
How does all that fit in?
Remember that expanding balloon analogy?
Yeah, the dots moving farther apart as you blow it up.
That's the one. So as the universe expands, galaxies move away from each other, right? And the light traveling between them gets stretched out. That's the redshift. And that stretching, it's directly related to the energy density decreasing as the universe gets bigger.
Okay, I see where you're going with this. So if energy is connected to time, then as the energy density decreases, time stretches, right?
Bingo.
That's why the light from those distant galaxies is redshifted, because we're seeing a snapshot of the universe when it was younger and time was flowing differently.
Precisely. Each galaxy is like a little time capsule showing us how time has stretched along with the universe.
This is just incredible. So we've got black holes, redshift. They both point to this wild idea that time isn't a separate thing. It's actually a form of energy. Is there anything else out there that supports this mind-blowing concept?
Actually, yeah. Remember we talked about the cosmic microwave background, the CMB, that faint afterglow of the Big Bang?
Yeah.
Well, that actually has some important clues about time and how things were in the very early universe.
Really? I'm picturing this baby picture of the universe. How does that tell us anything about time?
The CMB shows us that the early universe was, well, it was just ridiculously hot and dense, packed with energy.
Right.
But as it expanded, it cooled down, and all that energy got more spread out. That's what led to the bigger, cooler universe we see today.
Wait a minute, so we're back to energy density again. You mean because there was so much energy packed into the early universe, time must have been moving totally differently back then, too?
That's the idea. The CMB actually supports this. It shows these little variations in temperature and density, little ripples, and scientists think these are like the seeds of the galaxies and clusters of galaxies we see today.
Right. But it took, like, billions of years for those structures to form.
Exactly.
That huge timescale, that could be because time itself was stretching as the universe expanded and the energy density dropped.
It's pretty amazing when you think about it. The CMB is giving us glimpses not just of the early universe, but of how time itself has changed over billions of years.
Okay, so black holes, redshift, the CMB, they're all pointing to the same crazy idea that time is a part of energy. But what does this all mean for us, for how we understand reality?
That's the big question, isn't it?
Yeah.
It's something that scientists and philosophers will probably be debating for, well, forever, I think. But one thing's for sure, this concept of time as energy has the potential to completely revolutionize how we think about the universe. It could even lead to technologies that we can't even imagine right now.
Okay, now you're talking my language.
Right.
What about time travel? Is that even remotely possible if we could just figure out how to, like, manipulate energy the right way?
That's the ultimate question, isn't it? It definitely stretches our understanding of physics to the limit.
Yeah.
But if we're really serious about this idea of time as energy, then maybe manipulating time is more than just, a fantasy. It could be something real, something we can actually explore scientifically.
All right, I'm ready to explore those possibilities, even if it means diving into some of those time travel paradoxes.
Let's do it. We can look at the theoretical side, the potential applications, even what's standing in our way when it comes to, well, actually controlling time.
Welcome back, everyone. We've been on this wild ride today, exploring this incredible idea that time is actually energy.
It's been quite the journey.
It really has. We've seen how it explains things like black holes, cosmic redshift, even the cosmic microwave background. But now, let's get to the really exciting part. Time manipulation.
Right. This is where things get really, really interesting. If we take this idea of time as energy seriously, well, manipulating time, it's not just science fiction anymore.
That could be real.
It could be a real scientific goal.
Okay, but how do we even begin to, like, understand how to mess with time? It seems so complex, almost impossible.
Well, think about what we were talking about before, energy density. Remember how in areas of high energy density, like near a black hole, time slows down?
Right.
That's a key starting point. If, theoretically, we could figure out how to make those super high energy density areas, we might be able to manipulate time in that little pocket of space.
So we can make a time warp, like speed up or slow down time in a specific spot.
Exactly. Now, of course, the technology to do that, it's far beyond anything we have right now. We're talking about controlling energy on a scale that, well, it's mind-boggling.
But you're saying it's not impossible. Like,
Yeah.
based on what we know about physics, it could actually be done someday.
It's not impossible. Some researchers are actually looking into ways to do it, like using super powerful lasers to create those crazy energy densities, or even messing with gravity on a super tiny scale.
Whoa, that's both amazing and kind of scary. What could we do if we could actually control time? Possibilities are endless.
Just think about it. We could slow down aging, speed up healing, even time travel, although that opens up a whole can of worms with those time travel paradoxes.
Right, those pesky paradoxes. But even without time travel, think about the possibilities for science. We could watch events that take like millions of years to unfold, things like how stars evolve or how galaxies form.
Exactly. We could see all that within a human lifetime.
So we've learned a lot in this deep dive.
Yeah.
We went from time as energy to the possibility of, well, actually changing time. It's been an amazing journey. As we wrap things up, what's the main thing you want our listeners to take away from all this?
I think the most important thing is that we're always pushing the limits of what we thought was possible. For a long time, people thought time was this absolute thing, something that never changed. But now, because of incredible discoveries and, well, some really creative thinking, we're seeing time in a whole new way.
It's a good reminder that we still have so much to learn about the universe and our place in it.
And who knows what incredible discoveries are waiting for us out there.
So, to everyone listening, keep asking questions, keep exploring, and never stop being amazed by the universe and all its mysteries.
And if this deep dive got you thinking, check out the research we've talked about. See where it takes you. You might just be the one to make the next big discovery about the nature of time.
Thanks for joining us on this incredible exploration into the world of time and energy. Until next time, keep those minds open and stay curious.